Okay, we'll get started. And is the Git repository working out for you guys in terms of getting class materials and stuff? So on GitHub, under Smiles Chen, so you can go to GitHub Smiles Chen, and then just make sure you pick the 2018 fall repository, okay? And this is where I'm posting all of our course notes and updates and stuff. Just because a lot of these notebooks undergo changes during lecture, and so instead of having to upload and then re-upload on CCLE, I'm just keeping a repository, and everything you should be able to access. Okay, so we'll take a look at this one, week 2, 0201. Okay, and we're covering more stuff in the Python language. Okay, so we left off on Friday talking about lists and list methods, and lists, like in Python, like R, can contain objects of different types. Okay, so you can combine strings and numbers and things like that in a list. You can even nest other lists inside lists, and that's what we have. Okay, we looked at these methods. We have list.copy, list.append, list.insert, list.extend, list.remove, list.pop, and list.clear. So, in all of these things I have list written, but of course you're going to replace list with the name of the list. So if you're creating a list called people, it would be people.copy, people.append, people.insert, and these are how you make changes to the lists. Okay, so let me just we'll continue on. There's a few more methods. Okay, list.index and list.count will give you information about the contents of the list. Okay, so here, for example, I've created a list called fam, and this is contains information about our family members and their heights and meters, and so if I say fam.index Emma, it returns 2. Let me see. Okay, so because Emma is the object at index 2. Okay, it is case sensitive, so if I said capital Emma, it's going to give me back an error. It's going to say Emma is not in the list. Okay, so lowercase Emma gives me back index 2. That's how I would reference that. And so later on, if I do fam2, it'll tell me the object at fam index 2 is Emma. Okay. Okay. Likewise, here's another list. This is a list of strings, and it's got A, B, C, A, and you can ask, what is the count of A, and it will tell you how many times the object A appears in the list. Okay. It only does kind of like complete matches. So if I said, if I have A, B, C, A, and let's say do double A, A is not going to match the double A there. Okay, so it's just count how many times does this exact object appear in the list, and it appears 3 times, so it returns 3. Great. Yes.
When do you stick things into the parentheses, and when do you add the method onto the end of an object?
Yeah, so all of these things, you add the method on to the end of the object. Okay, there's a few functions that accept lists as arguments for the function, but all of these things that are methods, you say the name, and then you do dot, and then the method. Okay, but yeah, there are functions that will accept lists as objects, and we'll perform a function on them, and it's just a matter of usage and memorization. Okay, there's not like a quick and easy rule that says, oh, if it's this case, you're gonna put it inside the parentheses and these things. So it's just a matter of becoming familiar with the methods that lists have. Okay, so these are all list methods. But yeah, I don't have an easy thing. Okay. Fam2 is a list of lists. Okay. It's got Fam2 has 4 objects in it. Each of them is a list of 2 objects. So if I say, does Emma appear? It's going to say this object by itself does not appear in the list of 4, Fam2, so it returns 0 here. But if I say, does this list object, which is a list of 2 things, Emma 1.68, does that appear? It does, and it appears 1 time. Okay, so that gives me a 0 for the count and a 1 for the count. Okay, so index will tell you which index it is in 0 and count. Okay, you have a couple more methods. This one is you have sort and reverse. Okay, sort will take the list and sort them from least to greatest. Okay, if reverse will take the list and then just reverse all the items. Okay, these it's important to note that these methods affect the list in place. Okay, so we might be accustomed to using like a sort in R, but in R, when you apply sort to a vector, it does sort the vector, but it returns back an entirely new object. Okay, and the original vector is unchanged. And if you want the sorted vector, you have to capture that new object that's returned and then store it somewhere. Okay, when you apply one of these sort or reverse methods, it affects the list in place. So here I did, so fam is defined up here, starting with Liz and ending with dad in 1.89, and I just did fam.reverse, and then it reverses it in place. There's no, fam.reverse doesn't produce any kind of output, or I mean it does, but it's not there to capture. So let me, like, so if you just do fam.reverse, it doesn't show an output to the screen. Okay, and you just have to know that what it has done is it has reversed the list in place. And I think, let's see, and then, okay, and so it's been reversed. If I run this again, okay, it's not obvious what has happened, but then when you print it out, it has reversed it again, right? So we'll do that. Okay. Sort, again, we'll sort from least to greatest unless you use the argument reverse equals false. And if you do that, then it'll work. In this case, here fam is a list of mixed types, right? We've got numbers and strings, and it says I don't know how to do this. Okay, it doesn't know how to sort between strings and floats. Okay, so over here I've got a list of digits. If I sort the digits, okay, and again these things, if you just do sort, it doesn't show anything. Okay, so here's the original digits. This is our list of digits. Some digits.sort. It runs. It doesn't put any output to the screen. You have to ask for it, and you say print, and then it's sorted from least to greatest. Okay, and then if you want them to be sorted from greatest to least, you just do digits.sort reverse equals true. Okay, let me just show you what happens if you mix. Like here, I'm going to throw in a float. Okay. Okay, and it does it, and the items. So if I do some digits, like index 3 is the value 4, and this, if I ask for the type of this, what is its type? It's still an integer, okay? And if I ask for the item at 4, it's a float, okay? So it's sorted them, but it'll preserve the fact that they're integers and floats, and it doesn't necessarily upcast everything to float types, okay? So I'll write that. Preserves numeric data types. Okay, and then yeah, reverse. That's fine. Okay, and I think that's pretty much most of the list specific methods. Okay. All right. There's something called a tuple. Okay, in Python, and they look a lot like lists. Okay. They look a lot like lists. The only distinction between, visibly, is that tuples are defined with parentheses, or curved brackets, okay? So lists are defined with square brackets, and tuples are defined with curved brackets, or we might call them parentheses, okay? Tuples can contain mixed data types, so you can have strings and numbers and other stuff in there. The biggest difference is that tuples are immutable, okay? Meaning that once a tuple is defined, you cannot modify it, okay? So the list had all these methods, like append and insert and extend, sort and reverse, and all. These are things that modify the lists in place. So you just take the name of the list, you do append or you do pop or something, and it modifies the list. With tuples, you're not allowed to use any of those things, okay? They are defined and they are stuck, okay? So here I'm going to define a tuple, okay? Okay, it's got 0, apple, 2, cat, dog, 5, and 6, okay? And I tried to pick words that start with the letter of its index, right? So so if I say, what is the object at index 1, you can do that, okay? T, square bracket to kind of subset the tuple in this case, okay? And then here, you can slice it, okay? You can say, give me everything between basically the second and the fifth comma, and it gives you back, 2, cat, and dog, right? There are methods, okay? The index and the count method, they apply to lists, and they work on tuples because these methods do not modify the tuple, right? They return back information about the tuple, like what is the index of the object dog? The index is 4, okay? And then how many times does the number 5 appear? It appears once, okay? They don't modify the tuple. They return information about it, and so those methods work. All right. And then here I just have some examples of the difference between what it means to be mutable versus immutable, okay? So here are basically identical things, okay, except this one is a tuple, as indicated by the curved bracket, and then over here is a list with the square bracket, okay? And so with the list, you can say take the item at take the object at index 0 and change the value to 100. Assign the value 100 to it. Okay, that works fine. Okay, so now my list has the value 100, apple, 2, cat, dog. Okay, you try that with the tuple, and it'll tell you you're not allowed to do that. Okay, it says the tuple object does not support item assignment. Okay, if you try to use a method that modify lists in place, such as append or insert, whatever it might be, it's going to say tuple has no attribute append, okay, or it doesn't have a method like that. Whereas with the list, you can append the value x, and it modifies the list in place there. Okay. If you just start using commas, Python will create a tuple by default, okay? So here if I just say A is 1, 2, 3, 4, okay, I didn't even use parentheses or curved brackets, it creates a tuple, okay? So if I say, A is 1, 2, 3, 4, and I print out A, it throws the curved brackets on there, okay? And if I ask what's the type of A, it's going to say it's a tuple. All right. Okay, and so there's a question, when do we use the object name dot the method versus some function? So here's just a few functions that will support lists and tuples as inputs, okay? Really, I think they'll support any kind of iterable as input, okay? So you can do length for, how long is the iterable, and sum and sorted, min and max, okay? And so here I've got a tuple of numbers, and then I've got a list of words, okay? I could have created like a tuple of words and a list of numbers. It doesn't matter because the functions behave exactly how you would expect them to behave on both types of objects. The behavior of the functions are the same for tuples and lists. So the length will just tell you exactly how many items you have in there, okay? So I've got 7 here. Sum will add them up, not a big deal, okay? If they're numbers, if they're numeric, it'll add them, okay? And of course you can't sum strings. It's gonna say you can't do that, right? All right, sorted, okay? This might confuse some people because we have list.sort and you have the function sorted, okay? Sorted will allow you to give it a tuple or a list, and it will return another object that's been sorted out, okay? So here, some digits is a tuple, and I throw it into sorted, and it returns back, but the returned object is a list. Okay, sorry, I have the words switched up. Sorts the tuple, but does not affect the list or tuple itself. Okay. So it will sort the tuple, but then if I ask for the original tuple itself, the original tuple is unaffected. Okay, keeping kind of the rule or the property of tuples being immutable. So it's creating a new object, and if you want to make use of it, you've got to store that output. Okay, if you want to store this thing that says sorted some digits, you've got to store it somewhere, and then you can make use of it. And I'm pretty sure I can also do reverse equals true, and so with sorted you can also throw in the option reverse equals true, but it returns a list, okay, and if you want to make use of it, you got to store it. The original tuple is unaffected, okay. It'll work on strings, okay, just like before. It'll alphabetize them, all right, and then min and max will return exactly what you expect. As far as strings go, min will be if you alphabetize it, what's first in the alphabet, and then max will be if you alphabetize what's what is it going to be, what's the last object here, right? So when you sort the words, apple comes first and hat comes last. So hat is the max and apple is going to be the min for mins and maxes of strings, of a list of strings or an iterable of strings. Okay, is that all right? Difference between tuples and lists. And in most places where you're just looking for something to kind of store things, a list or tuple will probably work fine in a lot of cases. It's just if you need to be modifying that object, then it needs to be a list. Okay, but you can run for loops on tuples or lists, and they're going to behave the same way. Okay, we've got strings and string methods, okay? Strings are immutable. You can almost think of strings as like tuples, except there's like no commas spacing the elements, okay? And so, so every time you run, use a method, a string method, it produces a new string, okay? It doesn't modify the original string, it always produces a new string. So here, I said name is Stats 131, Python and other technologies for data science, and everything over here is lowercase and stats is all uppercase, okay? You call name.upper, it turns everything uppercase. Capitalize, it will capitalize just the first letter in the entire string, okay? Everything else is lowercase. There's title case, name.title, and that will capitalize the first letter of each word, okay? Or after every space, the next character is capitalized, okay? And it doesn't follow like normal English conventions where the words and is not capitalized and stuff like that. I don't know what the English, they don't capitalize what? Conjunctions and prepositions, or I don't know, whatever, okay. But what about articles? No, you don't capitalize those either, okay, oh, anyway. So anyway, and then, you know, lower does lower. And then again, if you check the original string is not modified, okay. Just like the other thing, you can ask for count E. Do I have index? You can also ask name name.index, let's say P, all right, and it will give you the index of the first instance of the letter P, okay. Wait, name.index. Python and, oh yeah. Okay, lowercase a, the first instance is there. Capital A, the first instance is there. Okay. Okay, and then there's a few other things, like you can test things, right? Does the string end with K? Does it end with E? False and true. You know, here's a, or does it start with a certain letter, okay? And all of these things are case sensitive. Strip removes white space before and after, okay? Removes extra white space, okay? And this includes like okay, so if you have triple quotes, you know, you can have right. Okay, so it has you know, white space additional lines, and but strip will remove extra white space, whether it's just spaces or like additional lines before or after in the string, okay? But if you put stuff like this, oops, okay, then strip only removes it from the beginning and the end and not in between. So if I ask to print this out, okay, it there's spaces in between my first and last name there, right? So all right, but we'll just okay, and then split defaults to splitting on spaces, and it will return a list of basically the string split up at the spaces. Okay, but you can give it other arguments. So here I've got the string 2, 3, 4, 7, 8. Okay, and so this is a string, and if I want to like use these as inputs or something, right? Like, I don't know, you're scraping some kind of document off the web or something, and it comes in as a string, and you want to say, okay, I want to actually use these values, okay? You can do string.split and say split on a comma, right? So this would be like a rudimentary CSV reader. If you're like going to read in lines from a CSV file line by line, and they're coming in as strings, you can say split on the comma, and you'll get the values, right? And then you've got to convert them into numbers, because right now they're still strings. Okay. There's other methods like is it alpha? Okay. Is alpha is does it have I think just letters and numbers only. So oh wait, no, letters only. Letters only will be alpha. Okay, so if I don't know, if you want to just make sure that the string has letters only, it's it will return true. Okay, let's see. Let's do name 4. If you throw in one of these, then it fails. Or a space. Okay, so if a space is in there or a number, it breaks. Has spaces and digits. Okay. All right, and then again, if you use triple quotes, whether it's like 3 double quotes or 3 single quotes, you can have strings that span multiple lines. All right, so here is lyrics from Hallelujah, and then you know, of course, if you want to make them upper, you know, all of these things work, right? And then you do string split, and it splits it up into different words. Okay. You can do split lines if you've got multiple lines, and it will, now I have a list. Each line is its own object in the list. Okay. You'll notice that by default, Python uses single quotes unless you've got an apostrophe in the word, and then it'll use double quotes. Okay. And so you can distinguish, like, generally that's what you use, right? Like if there's going to be an apostrophe in your thing, then you're going to have to use double quotes to define it. Otherwise, the single quote will kind of close off with the apostrophe. Or you can escape the quote, okay, using a backslash and stuff. Okay, but there we go. All right. Again, you can count letters. There's 2 methods for searching and finding characters in a thing. Okay, so index will tell you back the index where that letter appears, and find will also do the same thing. First instance of that letter. Okay, so in this case, lyrics to the song Hallelujah, the T here is the 8th letter, so it's index of 7, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8th character. So it's index of 7. Find and index appears to do the same thing. The difference is what it does if you give it a character that it can't find. Okay, so here I say, you know, search for the character $. Okay, that's not anywhere in here. So so it's gonna find returns back the value -1, okay, which is like something you can do with, right? So you can imagine some kind of conditional where you search for the letter and then it doesn't find it, and then you say you get back a -1, and then you can say, well, if the number is -1, that means it didn't find it, right? Whereas index will crash and give an error. Okay, it completely crashes it, and you can't do anything about that. So, depending on the situation that you're in, do you want to be able to do something with the thing that is not found, or do you want your program to halt if the index is not found? And this is a case where you should never be putting in stuff that that doesn't exist in the thing that you're searching over, right? And so this, if you're not asking the user for values to search for, and you are specifying, then it might make sense to use .index so that if something goes wrong, it halts the program, right? Okay, but of course, when you're asking users for input, you have to assume the users are stupid, and we'll give you bad numbers here. Okay. You can subset strings much like you would subset a list. Okay, so here I've got just A through Z as this, and you can subset it and just say, what is the character at index 0, and it gives you the first letter A. Okay, can you slice from basically 4 to 9? Okay, and again, there's no commas, but you have to assume, like, if there were, it's going to be between here and over here, and so it's going to give you the values in between. Okay, and negative indexes work as well, right? And you can leave off, when you do colon, it creates a copy and so on, and then you can run a loop over it, all right? And we haven't gotten into for loops or anything like that, and that'll be next, okay? But you can do a kind of, for x in the string, sliced from 0 to 5, then print, the character x plus an exclamation point, and it does that, right? But again, well, maybe I'll do this. Keep in mind, strings are immutable. So, like, if you wanted to change the first letter, which is the letter A, and you want to say, like, I want to change this to B, okay, you're not allowed to do it. Okay, so you have to kind of treat this like a tuple type of thing. You can't. You can't be modifying stuff like that. Okay, and then you can use math operators on lists, tuples, and strings. So math operators like addition and multiplication, right? So multiplication will generally duplicate stuff, and addition will generally appends things to these things, okay? And the behaviors across lists, tuples, and strings are similar. So here I've got a list, L1 and L2. L1 is ABC and L2 is DEF. And if I ask for L1 times 2, it gives me a new list where the values have been duplicated, okay? And it duplicates kind of like list-wise, not element-wise. So it's not going to be A, B, B, C, C. It's the entire list, ABC, and then ABC, okay? And then if you do addition for the lists, it just appends the two lists together. Okay, same thing with the tuple, okay? And it might feel weird because you're like, tuples are immutable. They are. Tuples are immutable. But notice we're not saying modify T1. This just returns an entirely new tuple, okay? It's an entirely new thing, so we're not modifying the currently existing tuple. We're just taking it and returning something entirely new constructed out of the currently existing tuple. So, just like the lists, multiplication and addition will duplicate and append, okay? You're not allowed to combine lists and tuples together. So if you say, give me L1 and T2, it's going to give you back an error. But you can convert lists to tuples and tuples to lists and whatnot, it's pretty easy. All you do is you just take the name of the tuple, throw it in the function list, and it turns it into a list. Okay, and that you can add. Okay, so you can take L1 and add list object of T2, and that works fine. Okay, and similarly we've got strings. Here I've got the strings A, B, C, D, E, F. When you multiplication, it returns back a new string where it just kind of duplicated the letters, right? And then addition, it just appends the strings together. Okay, so this might feel surprising for our users, okay, because we've never taken strings and then multiplied them by numbers, but it works, okay. And then adding strings also works, and it just pastes them together, okay. And so that's that. Okay, and then in the last bit we'll cover Booleans. Okay, so Booleans are your true and your false value, right? True, capital T, R-U-E, capital T, and then lowercase R-U-E, and then false, only the first letter capitalized, okay? I think the behavior of true and false, when you coerce them to other types, or when you cast them to different types in Python, behavior is expected, right? True will turn into 1, okay? Whether, if you say I want an integer, it'll give you 1. If you want a float, it'll give you 1.0. And if you ask for it to be a string, it'll give you the string true. False will become 0, 0.0, and false as a string. That's not surprising, okay? Other times you can take a different thing and turn it into a Boolean, right? So you want to take the output of some other thing and you convert it into a Boolean, okay? The Boolean of a thing, basically, if it's empty, it'll return false, okay? So an empty Boolean will give you false. A Boolean of the none object will also give you false, okay? As far as numbers go, only 0 becomes false. Everything else becomes true, okay? So Boolean of 0 is false. Boolean of any other number, 3, going to be true. 0.0 will be false, okay? But other things like -1, that's going to be true. And let's say you create not a number, like you do like infinity divided by infinity or something like that, and you get back not a number, then and you ask for the Boolean of that, that's going to return true, okay? Only 0 and 0.0 turn into false. Everything else will be true. For strings, okay, and this part might feel weird, only the empty string, okay? Meaning there's not even a space, okay? Not even a space between the open and close quote. That will return false. Everything else will return true. So you ask, what is Boolean of an empty, of just a space? That's going to be true. What's Boolean of the word false? Capital F-A-L-S-E. You'd think this might coerce into false. It doesn't, okay? Python sees it as, this is not an empty string. We're going to say true, okay? Okay, similarly for lists and tuples, only an empty list or tuple will give back false. Everything else will be true, okay? So here I've got an empty list. L is an empty list. And if I ask what's the bool of that, it's going to say false, okay? L2 is a list with one object false in it, okay? And I ask what's the bool of L2, it returns back true, okay? But of course, when you subset it and you say what is the object at item index 0, that's the object false, okay? And then if you ask, what's the Boolean of false, that's going to be false. But, this might throw people off, but you have to just keep in mind Python only will return false only if it's empty, okay? Only if it's empty. Everything else, it's going to say, it's basically, is there anything in the list? Is kind of how you have to ask it. Is there anything in the list? And if so, it's going to return back true, okay? Here, let me we'll even do, I know we're out of time. Okay, here I'm gonna put an empty, I think. Okay, so here, L3 is a list with an empty list inside. That's gonna return true. Okay, so we'll stop here.